Hello and welcome to another LeetCode problem. So today we're going to be doing problem number 55, jump game. And let's read it. You're given an integer array nums. You're initially positioned at the array's first index, and each element in the array represents your maximum jump length at this position. Return true if you can reach the last index, or false otherwise. And so they give these examples. So they're saying if you start at index 0, you jump 1 to get to index 1, and then you can jump 3 steps to the last index. And so for the second one, they're saying you will always arrive at index 3 no matter what. So if you try to jump from 3, you can get to 0. Try to jump from 2, you can get to 0. From 1, get to 0. And from 0, and you can't go from 0 to 4 no matter what you do. Okay. So how do we go about solving this problem? It's actually pretty straightforward once you realize one little trick. And you're going to want to read the problem carefully. So it's saying the jump is your maximum jump length, right? And so you don't necessarily have to jump the maximum jump length. You can jump any distance. So let's just look at this example, and it'll be pretty clear. So our goal is this index. So let's just say that whatever index our goal is we can have that value saved. So let's say we'll just call that G, and that's going to be index 4. Okay. So what we can actually do for this problem is realize, like I said, we can jump to any index. And so what would a brute force look like? Well, what a brute force would look like is we just try to jump to every single index and then see if we get a solution, right? So from 2, we have to start at the start, so we try to jump to 3, and then we try to jump over here. And then for each one of these, we'd have to, try all of them as well. So like, let's say we jump to 3, then for 3, we'd have to do 1, 2, 3, you'd have to try all of them. And so if you get some solution somewhere, then you would get a solution. And I think the time complexity of that would be, it would depend on the possible biggest number you can have. But if I can be 10 to the 5th and this can be 10 to the 4th, it's going to be like exponential, right? Because you can jump for any number. If you could jump 10 to the 5th times, it would be like 10 to the 5th, probably times 10 to the 5th or something, or even more maybe. But either way, we don't really have to concern ourselves too much with that. But the main thing we have to realize is what does a successful solution look like? Let's say instead of the 6, this number is 10. So we know that, like, if our goal is to get to here, anytime we get past here, that's success, right? Because if we can get past this number, like let's say this is 10, we just do the max. Then we know that, okay, if we got past here, then this is like the most we can jump. We can always just jump a little bit less and then get to here, right? So whenever we have a jump that's over this, that's going to be a success, because like I said, like we can lower this 10 to a 1 and get to a successful solution. So anytime you can get past the end, that's going to be success. So that's one success. And also if we get to the actual end, that's success as well. So let's go back here. And now let's think about, how do we really know how to get to the goal? And instead of going from the front, let's start from the back. And so we just go from every single number and we ask ourselves, can we get to the goal? And then if we can, what does that mean? So let's ask ourselves here. So from 4, can we get to the goal? Obviously, because that is the goal. Now from here, can we get to the goal? Well, yeah. Okay. And so if you can get to the goal from here, then wouldn't you say that any number that can get to here can also get to the goal? Right? Because if you know if you can get from the goal from here, then if you can get to here, now you've reached the goal. So we could actually say, instead of, so 4, this is actually index 4, not number 4. But now we know that we can get from here to the goal. Like I said, now that we know, as long as we get here, we've kind of reached the goal, right? So then we can, if we're iterating backwards, so from here we can, and our goal was 4, so it is 4. From here we can, right? We can try to be greedy, and we can just say, like, just jump as far as you can. And if we've passed the goal, like I said, if we've passed the goal, that means we can always jump a little bit less and get there. So if our goal is here, if we've passed it, we can jump a little bit less. And knowing that, let's see what this would look like now. So like I said, from here we can get here, from here we can get here. But now that we know that as long as we get here, we're at the goal, can't we just update our goal to be this index? So now let's say our goal is 3. Now we go over here. So let's delete this. So now we go over here. And we say, can we get to the goal? Well, remember, our new goal is this. Well, yes, we can. We can jump 1 and we can get to the goal. So then that means as long as we can get here, we can get to the goal, right? Because we know that from here you can get to the goal. So this is the new goal now. And so we can update that again to 2. Now we're over here. Can we get to the goal? Well, we can be greedy, right? And so we just jump as far as we can. Okay, so that's index 4. Is index 4 farther than the goal? And remember I said, if we can jump over the goal, we can always jump a little bit less and get to the goal. So yes, we can get to the goal. Okay, let's update our goal again to 1. Now from here, can we get to the goal? Well, we can go to index 2. Is index 2 greater than index 1? Yes. So we've passed the goal, which means we can get to the goal. Now our goal is 0. And so if our goal is 0 at the end, that means that from this value, we can get to our original goal. So from understanding that if you can get over the goal, like if you can get past the goal, that's the same thing as getting to the goal, because you can always just jump a few steps less. Because this is the maximum jump. We're not required to jump 2 or 3. We can jump up to 2. So if 2 passes the goal, we can just jump 1, and so on. If the problem was reworded where you have to jump this length, then it would be different. But because we can jump any single one, we can just be greedy, jump as far as we can, and if we've got to the goal or farther, then we could just say this is our new goal because now we can get there. So let's try the same thing for this second example. So once again, we're going to start with our goal being the index, not the value, but the index of the very last value, which is 4. So we ask ourselves, we go backwards. From 4, can we get to the goal? Yes, we can, but we're already at 4. So we're actually going to be starting our iteration from the space right before the goal, because we don't need to check, can we get to the goal from the goal? Obviously we can't, so we try from here. And we ask ourselves, can we get from here to the goal? Well, the most we could jump is 0, so we can't get to the goal, right? It's impossible, okay? But you can't just necessarily end here, because let's say this was like 200. Then you can still get to the goal, right? So you can't just, as soon as you get one number that can't get to the goal, it doesn't mean you can stop. You have to keep going backwards. So from 1, can we get to the goal? Remember our goal is over here still, because from 0 we couldn't get there, so we didn't update it. From 1, can we get to the goal? Well, we can only get to 0. And 0 is not the goal. So from 1, we can't get to the goal. From 2, if we just jump the most, can we get to the goal? No, we get to 0. And our goal is over here. And from 3, can we jump to the goal? No, we get to 0. So you can kind of see the way to do this problem is we just keep moving our goalpost backwards. And then if we can get to the goal, then we're going to keep moving it backwards. And if the goal ends up being the first element, that means we can get from the first element to the goal, right? Like if our goal ended up being over here or something, that means that we can get from here to the goal, but we can't get to here ever. So that's how we would do this problem. And let's look at the code now. It's pretty straightforward. So our goal is going to be length nums minus 1, right? Just the index of the last element. That's what we're trying to get to. We're trying to get to the last index. Okay. Now we just have to loop backwards through our array, as I said. So for, and I think we need an index, right? So we just say for I, v, in, actually we just do this, for I in range length nums. Now remember, we want to start at the second to last value, which is going to be this. We can technically start at the last value, but it's not going to do anything because you can always get from the goal to the goal. Okay, and so we need to ask ourselves if, and remember, we're just going to try to jump as far as we can. So if nums, what is this? Nums I. All right, it's actually going to be, yeah. Okay, so it's going to be the current index we're at, which is I, plus nums I, the farthest distance we can jump, is greater than or equal to the goal, right? That means, did we get to the goal or past it? That means that's a success. Then we just update the goal. And the goal is going to be I, right? Because we're iterating backwards, so we are always going to want to update to the goal to the leftmost goal possible. So if we can get from some number to the goal, we want to update that number to be the new goal. Okay, And now the last thing we have to do is we just have to return goal equals 0. So like I said, when we iterate backwards, in order to know if we can get there from the start, if we can, then the goal will be updated to be the 0 value, like I showed you in this picture, right, for this first thing. Like the goal will be updated to be here, 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 and then finally here if it's a success. But in this case, the goal will stay here because you can't get there from 0, and then from every number, the most you can get to is 0. So hopefully that makes sense to you, how this works. Like I said, once you kind of get the intuition, it's a really easy problem. You just have to get the intuition. And you have to recognize the greedy problem, and we're just moving the goalpost back every time. Okay, so let's actually do this. Run the code. What did we do wrong? So output false expected. It's kind of interesting. So let's see what we did wrong here, if we did something wrong. So goal equals length nums minus 1. Okay. For if I plus nums I is greater than or equal to goal, goal is the index. That should be right. Oh, right. So we need to, simple mistake, we need to traverse backward. Hopefully that works. There we go. Submit. Okay, cool. And so what's the time and space complexity here? So time, so we are just simply iterating backwards through the array. So that's going to be go of n, we're iterating one time. And space, we didn't make anything new, we just made a goal variable, so that's big O of 1. So that's all for this problem. Pretty straightforward once you get it, but definitely a good problem to practice to try to figure out if you can actually figure out that it's a greedy algorithm here. And if you like this problem, please like and subscribe to the video, and I'll see you in the next one. Thanks for watching.